Hello, welcome back. In this video, we're going to learn about casting. Let's go ahead and create a new class in the existing package and call it casting. We'll create our main method as always. Hit finish. We'll delete this guy. Let's go ahead and create an integer called int and make it 20, right? Now let's create a long and name it a long. It's equal to a int. So we're basically creating two variables. One is of integer type, another is of a long type. We are assigning the value of a long to whatever a int has, and there is no problem in this code because the range for a long is bigger than an int. So whatever value the integer holds, long can hold it. Now let's do this. Let's create another long. Let's create another int 2 and say it's equal to a long. We have an error. Let's see what it says. It says cannot convert from long to int. Since long has a bigger range, a long could possibly have a bigger number that the integer cannot hold. We know that the value is 20, but Java doesn't care about that. Java just says, hey, you were trying to assign a long number to an integer, and that's not allowed. Now, if we know that a long always will have a smaller number, and we know for sure that it can be converted to an int, and we want to take the risk because we know what's going to happen, we need to cast the type from long to int or convert the type from long to int. To do that, you do an open parenthesis here, type int. That's basically the type that you're trying to convert the value into. Close the parenthesis. Now the error is gone because now we have told Java, take whatever is in this, convert it into an int and assign it here, right? So the error is gone. This is basically what casting is. If you were to print a in 2, let's type a in 2, semicolon, save it. Let's do a right click, run as Java application. So the value is still 20, right? Now what if we were to make this value really big, like something that only a long can hold? Not here, sorry about that. So let's do a long equals a bigger number, right? So what we're trying to do is create an actual long number, and don't forget the L at the end to denote that it's a long number. So we have assigned the value of a long to a really long number, and we are trying to cast it to an int. Let's try to run it again. As you can see, the value is different, not really what we have in a long, because we have told Java convert this to an int, but since int has a smaller range, the value basically got converted into whatever int can hold and got displayed. Please keep in mind that int has a range from negative to positive. So if you go over the positive range, the value basically goes to the other end of the spectrum, the negative number, which is why you have a negative number here. This is basically what casting is. You would want to cast a bigger value into a smaller type only if you know for sure you're not going to lose anything, or if you are positive that losing is what you need, right? Losing the value or truncation is what you expect. Now, casting is not just limited to integers. It can be applicable to floating point as well. So let's go ahead and create a double, and say 2.6767, right? So this is basically more than 7 precisions, right, that float can hold. So float can hold 7 and double can hold 15, right? Now if we were to create a float and say it's equals a double, we're going to get an error saying we cannot convert. Now to convert it to a float, It's the same logic like here. Do an open parenthesis, type float, close parenthesis, right? Let's do a system dot out here and see what we get. Println if float is, and I need to put the double quotes here and not here. Now let's run it. You see if float is 6767676. We have only 7 here when we had more than 7 decimal point numbers, right? So there is definitely truncation happening here also, but we know that we want to convert the double to a float, so we're trying to cast it by using this. So that's basically what casting is. You would cast when you go from a higher value to a lower value. And casting is not just limited to primitives. They can be applicable to objects as well, which we're going to see in later videos. But this is basically what casting is. I would really encourage you to try this out with the several other types that we have, like byte and short. Define different variables and try to cast from one to the other to see what happens. But this is basically what casting is. Thank you. See you in the next video.